The universe is full of secrets, and some of the most incredible ones are hiding just beyond the reach of visible light. What if I told you that more than 1.5 billion unseen objects, from galaxies and newborn stars to some of the oldest stars in our entire galaxy, are sitting just out of reach of us, cloaked in cosmic dust? That's a little frustrating to think about, isn't it? Until now, that is. Because thanks to the European Southern Observatory's Visible and Infrared Survey Telescope for Astronomy, better known as VISTA, we can finally lift the veil on these hidden wonders. For the first time in human history, we have a pretty comprehensive infrared map of the Milky Way, one that pierces through the obscuring fog of space to reveal an unprecedented view of our galaxy and what lies beyond. Welcome back, everyone. Join me today as we appreciate how this first-of-its-kind map was made and take a look at some stunning images that reveal previously unknown stars across our galaxy. In September 2024, ESO's VISTA published the largest and most detailed infrared survey of the Milky Way ever undertaken. VISTA is part of the ESO's Paranal Observatory located in Chile, with its main focus being to map large areas of the sky. Using VISTA's infrared camera, known as VIRCAM, the team was able to peer through the dust and gas that permeates our galaxy and uncover some of the Milky Way's most hidden places. Traditional telescopes allow us to view space in visible wavelengths, which range between about 380 to 700 nanometers. But VISTA isn't like traditional telescopes. Instead of relying on visible light alone, VISTA operates at infrared wavelengths between 900 and 1200 nanometers, allowing it to detect otherwise invisible objects like stars obscured by dust and cold brown dwarfs, also known as failed stars, which don't emit enough visible light to be seen with a traditional telescope. To get an idea of the difference between visible and infrared light, take a look at these two images of the Lobster Nebula, or NGC 6357, one taken in visible light and the other with VISTA's telescope. We can see that in the infrared, the dust that obscures our field of view seems to disappear, revealing what look like hundreds of thousands, maybe even millions, of previously invisible stars. The map was created through the VISTA variables in the Via Lactea, or VVV survey, Via Lactea being the Latin name for the Milky Way, and its companion project, the VVV Extended Survey, or VVVX. The data collected from these two companion projects that make up the VISTA Infrared Survey have already led to the publication of more than 300 scientific articles. Unlike other recent space maps, this is one of the most detailed ones ever made. It's the first infrared survey to cover nearly 80% of the Milky Way's luminous mass and provides the largest infrared catalog ever made of our galaxy's central region. It allows astronomers to study our galaxy in finer detail than ever before. This survey gives us an accurate 3D view of the inner regions of the Milky Way, which were previously hidden by dust. It covers an area of the sky equivalent to 8,600 full moons and contains about 10 times more objects than a previously published infrared survey map. Our Milky Way consists of a central bulge, a dense, bright, puffed-up collection of stars, with a flat disk of two spiral arms around it. This image shows the area of our galaxy that was mapped in the survey. The red squares mark the central regions of the galaxy, which were observed by the original survey and then re-observed again by the extended survey. And the other square colors show areas that were only observed as part of the extended survey. From this image, you can see that these surveys have focused right on the central plane of our galaxy, spanning part of the disk and most of the nuclear bulge. But what has VISTA revealed? Argentinian astrophysicist Dante Minetti, who led the survey project, said, "We made so many discoveries, we have changed the view of our galaxy forever. And as much as I'd love to talk about all of them in this video, it's probably best I stick to some of the highlights." As part of the survey in 2015, VISTA turned its attention to the star formation region of Messier 20, also known as the Trifid Nebula, which lies about 9,000 light-years from Earth. Viewed in visible light in this image, we can see a beautiful nebula, glowing pink from the emission of ionized hydrogen and surrounded by a blue haze of scattered light from hot young stars. The cloud of gas and dust is obscuring the star-filled space behind it. Now look at this second image taken by VISTA's infrared camera. Peering beyond the clouds reveals a whole swarm of new stars. This image not only allows us to see through the Trifid Nebula, but by chance it revealed objects on the far side of our galaxy that had never been seen before. To their surprise, astronomers identified two faint, reddened objects as Cepheid variable stars. While they appear in the image to be just behind the edge of the Trifid Nebula, in reality, they are very distant, about 7 times farther than the nebula that once helped to block them from view. Cepheid variables are a type of bright star that is unstable. They brighten and fade over a period of a few days, or a few months, depending on their brightness. The first variable star we ever identified in modern times was Omicron Ceti, also known as Mira. It had been described as a nova until 1638, when Johannes Holwards observed it getting brighter and dimmer in a cycle that lasted 11 months. As for this pair of newly discovered stars, they are the only Cepheid variables that we have identified so far in this location, which lies beyond the central bulge, on the far side of our galaxy. And they can be really useful too. You can think of them as a kind of cosmic yardstick that can be used up to distances of tens of millions of light-years. If you know how long the star's pulsation period from bright to dim is, then you can infer its absolute brightness, as well as its age. You can compare absolute brightness to the apparent brightness, that is, the amount of light that reaches Earth, so you have a measure of how distant the star is. With a few reference points like these, we can build up a real picture of the scale of our galaxy and beyond. Looking toward our galactic center, a team of astronomers and data scientists found even more candidate Cepheid stars, 655 in fact. They then sorted these into one of 2 classes and found that 35 of these 655 stars were classical Cepheids, the younger of the 2. This was really exciting, especially since the galactic bulge was thought to contain mostly elderly stars that are at least 8 billion years old. Recording their pulsation periods, the team revealed that all 35 of these Cepheids were less than 100 million years old, and some may even be as young as 25 million years old. To put that in context, our own Sun is about 4.5 billion years old, so the youngest Cepheid has only been around for 0.6% of our Sun's lifespan. The team's exploration of Cepheids culminated in another major discovery. By mapping the 35 classical Cepheids they found, the team was able to trace a completely new feature in the Milky Way, a thin disk of young stars that stretches right across the galactic bulge. Buried behind thick clouds, it had remained unknown in all previous surveys of the region. In revealing this structure, combined with the discovery of older Cepheids, as I mentioned earlier, scientists have inferred that there has been continuous star formation along the midplane of the galaxy for the past 100 million years. There might also be even younger Cepheids that we haven't seen yet, as these stars would be so bright, they would be saturated in the VVV survey. The fact that we've found this thin disk of young stars within the galactic bulge is incredible. We used to think that the galactic bulge was an ancient feature of our galaxy's past, where exclusively old stars had formed separately from the stellar disk. But this finding reveals that things aren't so black and white, and that the formation of newer stars within the bulge could be a natural progression of our galaxy's evolution. But even more inspiring, perhaps, is a discovery by the VISTA infrared survey that lies at the ancient heart of our Milky Way galaxy. In 2016, for the first time, a type of ancient star known as RR Lyrae, another variable star, was discovered in the center of the Milky Way galaxy by a team led by astrophysicists Dante Miniti and Rodrigo Contreras Ramos. This type of star is usually found in globular clusters, which tend to orbit the outer regions of the galaxy. A globular cluster is a tightly packed group of stars that contains tens of thousands to millions of stars bound together by gravity. They're also really ancient, containing a stellar population that can be over 10 billion years old. The team found 12 RR Lyrae stars during the VVV survey, which suggests that they might be the remnants of an ancient globular cluster, right at the heart of our galaxy. This finding also provides evidence that might help astronomers to decide between the two competing theories of how nuclear bulges form. Whilst some scientists think that the nuclear bulge forms early in galaxy evolution, when multiple smaller galaxies violently collide, others say that it forms gradually over time, where gas is funneled inwards to trigger star formation. Finding these ancient stars here suggests that the bulging center of the Milky Way likely grew through the merging of primordial globular clusters, therefore supporting the first theory. So not only does it hint at our own galaxy's beginnings, but it also offers compelling evidence into how these galactic bulges might form in other similar galaxies. Speaking of ancient stars, VISTA was able to find 2 new globular clusters as part of the infrared survey in 2011. In this visible light image, a known globular cluster, UKS1, can be seen on the right as a hazy red splotch. This cluster had been the dimmest known globular cluster until the new discoveries. Now, compare this same patch of sky, but this time in VISTA's infrared light. Suddenly we can see what we have been missing. Much more faint than the known UKS one, we can make out a second globular cluster, this time in the upper left of the image, which has been named VVVCL001. Another globular cluster, aptly named VVVCL002, was found soon after, and this small, faint group of stars may be the closest known globular cluster to the center of the Milky Way. Did you know that there were only 158 known globular clusters in the Milky Way before these new ones were found by VISTA? For the survey to identify 2 more of these rare stellar objects is quite a significant accomplishment. Within this central region of the galaxy, it's easy for younger stars and cosmic dust to obscure globular clusters, especially since their age prevents them from shining as brightly. But now that they've been revealed, these features bring exciting possibilities for further study. It could just be an illusion of perspective, but scientists have wondered whether VVVCL001 is gravitationally bound to UKS1. If this is the case, then they would be the Milky Way's first known binary globular cluster pair. We've found binary clusters in other galaxies, like in Centaurus A and the Large Magellanic Cloud. But scientists think it might be when these gravitationally bound clusters collide that we get the most massive globular clusters, like the spectacular Myal 2 in the M31 galaxy, so studying a binary cluster right in our own galaxy could produce some amazing insights into this process. It's all speculation at the moment, but it's definitely cool to think about. In addition to globular clusters, the VISTA infrared survey identified a multitude of other types of star clusters. At least 96 new open or galactic clusters have been found, which typically contain fewer, younger stars, and are much more common than the globular type. Like the globular clusters, they had been hidden by cosmic dust, but VISTA's 4.1-meter infrared telescope has lifted the curtain to show them in all their glory. Take a look at just a few of the stunning images we now have of these objects. One of these open clusters, VVVCL003, is much more difficult to make out in images compared to the tightly packed globular clusters. Try and see the density differences in the stars in this section of the image compared to the surrounding regions. It was found by VISTA 15,000 light-years beyond the Milky Way's center, and also happens to be the first of its kind to be discovered on the far side of the galaxy. The sheer scale of this survey is staggering. Covering a vast region of the sky and mapping more than 1.5 billion objects, this data has already led to fascinating discoveries that are rewriting our understanding of the Milky Way and beyond. And that's just the tip of the iceberg. This survey will serve as a foundation for future telescopes and observations, which will hopefully be able to expand on VISTA's legacy with even higher resolution and sensitivity. We now have the most detailed 3D map that has ever been made of the Milky Way's structure and objects, one that unveiled hidden wonders previously beyond our reach, and scientists are already uncovering new galactic features and reshaping our understanding of the galaxy. With the information from this groundbreaking infrared survey, as well as the recent work from ESA's Gaia mission in visible light, it's an exciting time to be an astronomer, and we can expect a flurry of new insights about our own galaxy and the universe as a whole. VISTA's infrared observations have unveiled dozens of hidden star clusters and millions of previously unseen stars. They have revealed new stellar nurseries where stars are born, and they have broadened our understanding of the formation of our Milky Way. Looking at the sky through different wavelengths has brought about a new era of galactic exploration, and I can't wait to see what else astronomers and data scientists are going to uncover thanks to VISTA's 3D map.